Welcome to Textbook Engineering Problem, where we explore complex engineering problems and discuss different methods for solving them. In this video, I'll be breaking down a problem and discussing different ways to tackle it. However, keep in mind that there is no one correct path for some of these solutions, and I encourage you to share your own insights and thoughts in the comments. Together, we can learn and improve our problem-solving skills. So, sit back, grab a notebook, and let's dive into today's problem. Today we're working out of Elementary Principles of Chemical Processes 3rd edition, and we're doing problem number 3.30. The problem statement says, the little-known rare earth element nausium, atomic weight equals 172, has the interesting property of being completely insoluble in everything but 12-year-old bourbon. This curious fact was discovered in the laboratory of Professor Ludwig von Schlemasel, the eminent German chemist whose invention of the bathtub ring won him the Nobel Prize, having unsuccessfully tried to dissolve nausium in 7,642 different solvents over a 10-year period. Schlemasel finally came to the 30 milliliters of old aardvark bottled in bond that was the only remaining liquid in his laboratory. Always willing to suffer personal loss in the name of science, Schlemasel calculated the amount of nausium needed to make up a 0.03 molar solution, put the aardvark bottle on the desk of his faithful technician Edgar P. Cetera, weighed out the calculated amount of nausium and put it next to the bottle, and then wrote the message that has become part of history, etc. ad nauseum. How many grams of nausium did he weigh out? Neglect the change in liquid volume resulting from the nausium addition. That is one heck of a problem. This problem is actually super simple, but they added a whole backstory behind it. In some ways it's pretty cool, because it keeps you awake as you're doing your homework, so that's nice of them. In some ways it makes the problem a little more complicated because you're trying to figure out what's the actual important information in this text. Alright, so I'll go ahead and parse through this and write down what I think is important. Okay, so from all of that text, the only things that are important are the volume of the bourbon that he used, the concentration that he ended up with, and the molar mass of the nausium. It's pretty easy from this point to see that we just need to do some unit conversions, do a dimensional analysis, and figure out how much mass he added to the bourbon. Okay, so we see from here that if we start off with the concentration, we can do the unit analysis and end up with the mass. So we start off with concentration. We convert the molar into moles per liter. Then we've got 30 milliliters of volume that we're working with. So when you multiply the amount of volume by the concentration, you get the total amount of solute that's in there. Okay, so then we do a unit conversion. Then we convert the number of moles of the solute that we have into the mass by using the molar mass that they gave to us in the problem, and we multiply all this together, and we end up with the mass of the amount of mass that he added, that he told Ed to add. Alright, so that is it for problem number 3.30. Thank you for watching, and I hope you found this video helpful in your problem-solving journey. Remember, there are other routes you can take to arrive at the same correct answer, and I encourage you to leave a comment with any additional insights or questions you may have. Also, if you have any specific engineering problems you would like me to cover, please let me know in the comments. Your feedback is valuable, and I look forward to continuing the conversation with you. Don't forget to like and subscribe for more engineering problem-solving videos. Thanks again, and I'll see you in the next video.